The title of the presentation is The Danger of Combining Flame, Heat and Chemical Protection. So we'll begin. My name is Martin Lill, for those of you that don't know me. Good morning or good afternoon, good evening, wherever you are in the world. And thank you for attending. It is perhaps a shortcoming of testing for any standards, whether it be EN standards or any other standards, that generally PPE is tested in isolation, which is not how PPE is used in the real world, because in the real world, invariably, PPE must be worn with other types of PPE together. And sometimes there is a risk that one type of PPE can adversely affect the performance of the other. And that's always a risk that safety managers and users of PPE should be aware of. But one particular situation that I'm going to talk about today in detail is when you need to combine flame and heat protection with chemical protection, because that presents a real problem and in fact a real danger. So we're going to talk about that and how to handle it. So we're going to look at some specific parts of this issue. First of all, we're going to look at the problem, what it is, why it happens, and the proof that it is a problem. Excuse me. And we're going to look at the solution, the proof of the solution. We're going to look at some of the cheaper options in the market that actually, when you analyze them, don't work very well. And then finally, I'll do a little bit of selling and talk about a little bit about our Lakeland Pyralon option. So let's carry on. So the problem, what is it? What is the problem? Why is combining FR workwear and chemical protection a potential problem? Well, let's start with a little bit of background. In many industries, and particularly in the petrochemical industry, protection against flame and heat, the possibility of a flash fire, is pretty much everywhere. It is standard to wear an FR protective garment, something like a Nomex suit or FR cotton or one of those types of suits, normally certified to EN 11612 in terms of EN standards, and that provides you with the FR protection that you need. But in many applications, you also need chemical protection. Obviously, in the petrochemical industry, there are lots of chemicals around, and you need protection against the risk of splashes, sprays of those chemicals. So you need both types of protection at the same time. So what do? Well, the obvious solution is what quite commonly happens pretty much all over the world, and that is this. You need your FR protection, so you wear an FR EN 11612 certified garment, something like a Nomex suit or FR cotton. But you also need your chemical protection, so you select a type 5 and 6 garment or a type 3 and 4 chemical suit, and you wear that over the thermal protective garment or TPG in order to give you the chemical protection. So you got your FR garment for the flame and heat protection, you got your chemical suit for the chemical protection. So there you go, job done, no problem. Now, if only life, and particularly if only safety, were that simple, because that doesn't solve the problem. And in fact, it creates a worse problem. Why? To answer that question, let's ask a different question. There are lots of different types of chemical suits available in the market. The question is, do those coveralls burn? Let's watch a short video, which I think answers that question. So I think that video answered the question. What you saw there were fabric samples from 3 very commonly used coveralls in the marketplace. And the problem is that pretty much all of the limited life, disposable, chemical protective workwear in the market is made of polymers. It's made of polyethylene, polypropylene, very often, or a mix of both, or other types of polymers, which are all thermoplastics. So, of course, when you put a flame to them, they burn, they melt, and they drip that molten burning plastic. And that's the problem. Because basically, when you do that, when you combine the FR workwear with the chemical protective workwear, if you come into contact with flame, the outer garment, the chemical protective workwear, will ignite and it will burn and it will drip molten plastic onto the thermal protective garment below, and it will transfer heat energy through to the wearer, and basically it compromises the thermal protection. So essentially, the problem is, by doing that, you will seriously compromise FR protection, and perhaps fatally. But what about the proof of that? We've seen the video, but how can we prove that that is actually a problem in the real world? Well, we can prove it with thermal mannequin testing. Now, thermal mannequin testing is a type of testing that it's optional in EN 11612. It's actually compulsory in the equivalent test in North America, but it's a great way to assess the relative level of protection provided by thermal protective garments. I'm just going to show you another short video which shows you how this type of testing works. Okay, so it's the only way to be sure indeed. And let's see if we can. Okay, so we've stopped. Okay, so there we are. Good. So thermal mannequin testing is great. It's very useful because it gives you an indication of the relative level of protection against flame and heat of whatever garments you're wearing. And it produces a body map, which you saw in the video, and we'll see more of those, that shows where the burns would be, and it indicates pain, first, second, and third degree burns, and so on. So what we've done is this is a great way to discover the effect of wearing different types of coveralls over a thermal protective garment. So we've commissioned precisely that testing to indicate the effect of wearing those coveralls over a thermal protective garment. And these are the first 2 test results we got. First of all, we tested a TPG, a thermal protective garment only, tested it on its own. And this was the result we got. This was actually a Nomex 3A suit, I believe. And we got a predicted body burn of 37% with second degree burns only. So that's our base point. That's the starting point for the testing, so we can then see what the effective is of wearing different types of coveralls over the same thermal protective garment. And the first one we did was a standard disposable type 5 and 6 garment, a microporous film garment, which is very commonly used in the marketplace. So you've got your type 5 and 6 protection and your flame and heat protection, you think, but this is the result that we got. We actually increased the predicted body burn from 37% to 53%. and we added third-degree burns, more dangerous third-degree burns. And you can see on the map there, the darker areas in red are where those third-degree burns occurred. That is where the material of the microporous film garment has melted, it's burned, it's dripped and stuck onto the material of the thermal protective garment and continued to burn and transferred more and more heat energy through to the wearer, resulting in deeper burns. So we've increased the body burn from 37 to 53%. That is a 43% increase in the predicted body burn simply by wearing a standard disposable suit over the thermal protective garment. And we've made the burns worse. Not only have we got more burning, but they are deeper. They are now third-degree burns. So I think we proved that the problem is real. Wearing standard chemical protective clothing over thermal protective workwear will seriously compromise your thermal protection. And that's the problem. So what about the solution? How do we solve it? Well, the answer is secondary FR workwear. Which is what? What is secondary FR workwear? Well, basically, this is chemical protective clothing that uses fabric that will not ignite and burn. That's essentially what it is. So its primary use, its primary purpose is to protect against the chemicals, but it's designed so that it doesn't ignite and burn as normal protective, disposable protective clothing will. So you can safely wear it over your thermal protective workwear. It is certified to EN 14116. So this standard doesn't define protection against heat and flame, but it assesses how the flammability of the fabrics for workwear. And basically, there are three index. Index 1 requires in the vertical flammability test, which you can see in the image there, it requires that there is no burning to the edge of the sample, there is no melting, and there is no dripping. That's the basic requirements. So, what about a visual demonstration? Well, we saw in the first video how standard chemical suit fabrics will ignite and burn and drip. So what about a good quality secondary FR workwear coverall? What happens to that in the same test? Let's watch another little video. Okay, so I think you saw there, if I can manage to get onto the next screen. No, we don't want to watch it again. There we go. Okay, so compared to the first video where we saw how the standard chemical suits will burn, you would see on that one, it does generate a hole. You do get a hole, the fabric chars, but you can see it doesn't ignite and it doesn't burn, it doesn't melt and drip, it simply chars. Okay, so it doesn't generate a problem in the same way by igniting and continuing to burn. And that's what standard, or that's what secondary FR workwear should do. But what about thermal mannequin test results? We've seen the visual test, that's positive. What about thermal mannequin testing? Well, we saw in the first two tests with the thermal protective garment on its own, we got 37%. And then by wearing a typical disposable type 5 and 6 coverall over it, we got 53% body burn, and we increased the burns from second to third degree burns. So what about secondary FR workwear? Well, this is another product in the range. This is Pyralon CRFR, and the result was this. We've actually reduced the predicted body burn to 24%. So we've improved the thermal protection. Let's just summarize that, what we've seen on a graph. With the thermal protective garment only, this is the garment you use for your flame and heat protection, we got a predicted body burn of 37% with second degree burns only. By wearing a standard disposable type 5 and 6 suit over that, made of a polymer, plastic, we increased the body burn to 53%, a dramatic increase. And we also got deeper burns, worse burns, third-degree burns. But when we wore a properly designed, engineered secondary FR workwear garment over it, we reduced the body burn to 24%. And there were second-degree burns only. I think that is pretty conclusive that the problem that standard workwear over TPGs cause is solved by proper secondary FR workwear. So basically, we've proved the point. By wearing standard disposable or chemical protective clothing over a thermal protective garment, you get an increase in predicted body burn. You actually reduce the thermal protection. But with a properly engineered secondary FR garment, you decrease the predicted body burn. You've actually improved the total thermal protection as well as getting the chemical protection that you need. So we've solved the problem. However, again, safety is never as simple as we would like it to be. And there are some other options on the market, some low-cost options that meet the same standard, that EN 14116 standard. But how do they perform? How do they perform, and how do they perform in a visual test? Let's just look at what these are, first of all, because there are two different types of garments that are certified to EN 14116, really. The first is the specialized secondary FR workwear garments, such as the Pyralon range, which I'll talk about at the end. And there are also what we call FR SMS garments in the market. These are SMS coveralls, standard plastic coveralls that have an FR treatment. The secondary FR workwear versions are based on alternatives to polymers, not the standard plastic polymers, but different fabrics that are designed, they are engineered for their FR properties, whereas the FR SMS coveralls are still based on thermoplastic polymers. The FR properties in the specialized garments, such as Pyralon, are intrinsic, whereas on the FR SMS coveralls, they've just taken a standard plastic coverall and put an FR treatment on it. So they rely on a topical treatment. Here's where it gets interesting, because the specialized garments, such as Pyralon, they fully meet all the requirements of the EN 14116 standard. But interestingly, when you look in detail at the certification of FR SMS coveralls, and I will say this is the case with everyone we've looked at, though I confess we probably haven't looked at them all, but basically they do not meet all of the requirements of EN 14116. And finally, we proved that the secondary FR workwear, the Pyralon types, the specialized types, they do actually work in terms of measuring predicted body burn, whereas actually when you analyze the FR SMS coveralls, they make very little difference. So let's look at those last 2 points in a little bit more detail. First of all, it is a fact that all the FR SMS garments that we've looked at that are available in the market, and this includes the major brands that are out there, they do not meet all the requirements of the standard. So to explain this, in 2015, there was a new version of the standard that was introduced, and that introduced some additional requirements. And specifically, it required that as well as the fabric meeting that flammability test, the zip, the components, the seams must as well. So in that test, as well as doing a test on the fabric, you have to do a test on fabric with a seam in it and fabric with a zip in it. And it needs the same requirements: no dripping, no melting, no burning, etc. And in fact, there's a requirement that the zip must also function after the test. So that's a requirement that was introduced in the 2015 version of the standard. But actually, when you look at the certification of FR SMS garments, and I will say, as I say, this is the case with everyone we've looked at, they don't meet those new requirements. And if you doubt me, here is a clip from a little snippet from the user instructions of one of those garments. I've redacted the name for obvious reasons, but you can see here it says meets the requirements of EN ISO 14116 2015 Index 1, with the exception of clause 0.6.1.4. The coverall did not pass the seam flammability test. So in other words, we've got a curious situation here, because the situation is that a new version of the standard was introduced with new requirements, but some of the PPE in the marketplace doesn't meet those new requirements. So it's been allowed to be certified without meeting the new requirements in the new version of the standard. So really it's certified to the old version of the standard, not the new version of the standard. And yet certifying to an old version of a standard is not supposed to be allowed. Now, the question about how and why that happens is for another discussion entirely. I could do a whole webinar just on that subject. But the point is here, those FRSMS garments, and they are widely used in the marketplace because they are lower cost, do not fully meet the requirements of the standard. And my guess is that many people don't realize that. But what about how do they actually perform? What about a visual test like we've seen with the other garments? Well, this is the final video, and this is one of these FRSMS coverall fabrics. We've bought garments in the market and taken fabric samples from them, and here's what happened. Curious. Come on. There we go. Very curious indeed. That's a sample of fabric from an FR garment. So we saw in the first video how the standard chemical suits burn and melt and drip. We saw with the properly engineered secondary FR workwear, the Pyralon garment, how there was no burning, no dripping, no melting. And then we looked at the commonly used FRSMS garment fabric, and in fact there was still melting and dripping, which you wouldn't expect. But what about thermal mannequin testing? How does it perform with this testing? Well, we did a separate bank of testing a little while ago to assess the effect of wearing different brands of type 5 and 6 coveralls over the same thermal protective garment. And we tested 4 garments. We tested a standard disposable coverall, a flash spun PE, commonly known as Tyvek. We tested a standard SMS coverall made of polypropylene. We tested an FR SMS coverall. So this is the same as the second one, but with an FR treatment. And finally, we tested another Pyralon a Pyralon coverall, this time Pyralon +2. So all of these garments in these tests were worn over the same TPG, and they all offer similar type 5 and 6 protection. So what was the results? Well, the first one, flash spun polyethylene, we got 23.9%, and you can see in the 2 colors on the map, there are 2nd and 3rd degree burns. The second one, and both of these, of course, are not FR garments. The second one, we got 20.9% predicted body burn, and again, 2nd and 3rd degree burns. Now, you would expect a slightly lower burn with that product because it's a less dense material. There's less material there to burn. But then we tested the FR SMS coverall. This is the FR treated SMS coverall, certified to EN 14116, and we got 19.6%. And there are still 2nd degree body, 3rd degree body burns. And then with the final test with the Pyralon, 7.4%. So with the properly designed secondary FR workwear, you get a dramatic reduction in the predicted body burn. So let's just summarize a couple of key points out of that testing. The astonishing thing really is that when you look at the standard SMS coverall compared with the FR SMS coverall, there's almost no difference in the predicted body burn. You're not really achieving anything, despite the fact that the second one is FR treated. But compare that to the properly engineered Pyralon garment, and you get much lower predicted body burn. There's a dramatic difference. So what we've learned when it comes to these low-cost FR-treated SMS coveralls, first of all, they're not fully certified to the standard, and you can check that easily by reviewing EN certificates or user instructions. If we do a flammability test on them, a visual test, we can see they actually don't perform that well. They still get some burning and melting and dripping. And finally, in the all-important thermal mannequin tests, there's actually no difference between the non-FR version and the FR version. So it's not unfair to say those low-cost garments, you get what you pay for, they don't work very well. So if you're paying more for your FR SMS garments than SMS garments, you're not really getting much for your money. I just thrown this slide in at the last moment because I don't know anything about it, but I learned this literally last night. I got a message from the US saying that there is a new ASTM standard for secondary FR workwear. I'm going to find out about that, and I'll post something about that on my LinkedIn page in the next couple of days. So information to follow on that. It'll be interesting to see what's in it. So finally, I've mentioned Pyralon a few times. This chap here is our Pyralon XT garment. This is the Lakeland range of secondary FR workwear, which I like to term as the only secondary FR workwear you can trust, which I think once you've seen that thermal mannequin testing, I don't think it's an unreasonable thing to say. So what is it? Well, it's a range of clothing for chemical protection. Its primary purpose is to protect against chemicals, but it is also EN 14116, so it will not ignite and burn. There are options for type 5 and 6 chemical protection and type 3 and 4 chemical protection. And it's not based on plastic. It's not based on polymers. It's actually based on viscose, which is a little counterintuitive because viscose is wood pulp, which you wouldn't think would give you the right properties, but it's that enables it to be engineered with these specific FR properties. But the key point is that it's not based on plastic, so it doesn't create the problem. It will not ignite, it won't burn and drip molten plastic because it isn't plastic. It's got a heat tolerance temperature well over 200 degrees Celsius. That doesn't mean to say it will protect against that temperature. That's a different issue, but it won't melt or drip or burn at that temperature. Most standard chemical suits and disposable suits have a melting point somewhere over 100 degrees, but much less than 200. And as an added benefit, Pyralon also has intrinsic FR properties, anti-static properties, which will last the life of the garment. There are 4 products in the range: Pyralon Plus 2, Pyralon XT, Pyralon CRFR, and Pyralon CBFR. The Plus 2 and XT give you type 5 and 6 protection and fully certified to 14116. CRFR and CBFR, type 3 and 4 chemical protection and certified fully to 14116. And particularly the CBFR offers a very high barrier to a whole range of hazardous chemicals. So this is a unique product. There are very few products that will give that level of chemical protection and provide the safety to be worn over FR workwear. And in fact, it's also certified to EN 11612. So it will also provide some level of thermal protection as well. But basically, these garments can be safely worn over thermal protective garments. You can wear them with confidence, knowing that not only will they not actually compromise the thermal protection, they will improve the overall total thermal protection. I will mention this, the guide to secondary FR workwear. This is our guide to this whole subject about secondary FR workwear. You can download it from the link there. I'll also try to remember to post a link to that download page later on my LinkedIn page. But basically, the Pyralon range of garments that Lakeland make, they are the only secondary FR workwear you can trust. I think you've seen that in the videos and in the thermal mannequin testing, that these are the only ones that actually work in actually improving thermal protection and that you can wear safely over your thermal protective garments. So that's the end of the presentation.